Supplemental Math Videos from Circle Christian School. Today's video is how to set up your 3-ring binder and just a reminder of what your homework front page should look like. All right, I think you all are probably fairly well versed in being able to graph a coordinate. For instance, if you had a coordinate like 3 and 5, realize that this is the x and this is the y. So you're going to go over 3, it's just like Battleship, and then you're going to go up 5, and that's going to be where your little point is. You guys are pretty good with that. The next thing is to use a table of values to graph an equation. And what I do there is actually use something like a TT table. It's very much to your advantage to always change an equation to being y equals. So you might have to do the do change. I'm going to use negative 2x plus 1. Now with the TT table, it's a little bit bigger than maybe some of the other tables that you have used in either the Chalkdust or other math. You have to have some inputs, you have to have some outputs, and we're going to put inside here our math rule, our function, negative 2x plus 1. I like to find things that are, for my input, I like to do something that's rather negative, something neutral, something positive. And then I like to build a template. You know, I'm a template fan, which means I'm just going to take the x away in all of these. And I'm a bit of an assembly line type of person. I'll get it all made up before I have to do things. And then I'll put things in. So I'm going to put my input, what my x is. I have a negative 1 here, I have a 0 here, and I have a 1. And of course that's going to give us something out over here on the y. Negative, negative, positive, 2 plus 1 is a 3. 0 plus the 1 on the next one is going to give me a 1. And a negative 2 plus 1 is going to give me a negative 1. Notice how inside here all of these are going down by a negative 2. Totally connect that with this cute little guy right here. Oh my goodness. Everybody's going down by a negative 2, and my slope was a negative 2. We're actually going downstairs. And that's how you make a table of values. The next thing that we're going to do is find the slope and the intercepts of a line. One way to find the slope is actually by doing the change of an equation. So for instance, if you had 2x plus 3y equals 16, then I'm going to do that literal expression thing. The whole thing is to change it back into that form that is y equals mx plus b, because that gives you the slope right here. That's one way. So I'm actually just going to get the y all by itself. There's my little isolation bubble. Negative 2x and a negative 2x, both sides, is called solving a literal expression. We're not really solving it. What we're doing at this point in time is just moving things around on it. And notice that I did not put the negative 2x under the 16 because they're not like terms, and I like to add and subtract vertically. So these are going to cancel out, gives us the 3y. We're getting closer to a y equals type of thing. It's the first key on your calculator. So I'm just going to make things proper and put the thing that has an x to it first. And then my 16 plus 16, it's a positive 16. Positive 16 is a plus. We still have to get the 3 by itself. So I'm going to divide everybody by a 3. United we stand, divided by all. So that says goodbye. See, now I have my cute little y all by itself. I have my slope, so far up and down, so far back and forth. And now I know exactly what my slope is right here. So far up and down, and so far back and forth. That is one way to go and do it. Another way to go and do this is actually to use the slope formula. Which is the difference of the y's over the difference of the x's. I also like to make a template for those at the same time too. So say for instance, maybe we have a -3, +4 is our coordinates, and our other coordinate, because any 2 points make a line, might be -1, -4. I like the number 4, so you'll probably see that a lot. And we're now going to make sure you label everything. This is my first x and my first y. This is my initial point, and that's why it has the little 1 down there. It's called subset 1 for this, and it just means cardinal order. And this is going to be my second point. It's the terminating point. And what you're going to see me always do is make some sort of template. And the template is the change of the y's over the change of the x. I'm going to put the minus sign there. And now I'm going to plug things in. So I'm going to start with my second y, because it's y2 minus y1, -4. If you do it this way, and you also use the different colors, you'll notice that you won't have any integer problems. And the next one's a 4. Oh my, okay. And then we're going to do the second x right here, which is going to be a -1, and then the first x, -3. See how that kind of keeps the integers happy right here? And then we're just going to evaluate -4, -4. It's going to give us a -8. And you can always do the little chalk dusty thing, make this a plus, because a double negative always gives us a plus. So -1 plus 3 is a 2. And so therefore our slope equals a -4. One way to go find the slope. Also, to find the intercepts of any equation, the x-intercept, you always put 0 in at the y. So let y equal 0. And for the y-intercept, you're going to put 0 in at the x. So for instance, if you had something like -2x plus 6y equals 12. And this is very handy when you have that standard form, especially if we have lots of pretty numbers in here that, you know, the 2 and the 6 kind of relate to the 12. This is a good way to do that. Otherwise, it's better to do the do change and do a slope intercept. So what I'm going to do here is actually put a 0. I'm going to go find my x-intercept. And that means I'm actually going to put a 0 in where my y is right here. And this generally just makes that guy go away. So all you're going to see is the -2x and the +12. So -2x. And if you just kind of put your thinking caps on, you would go, well, that's going to be a -6. So the coordinates for this is you got a -6 for the x, and you put a 0 in for the 4. And the next one is that we're going to do the y-intercept. And again, I'm going to put a 0 in for the other guy. So I'm going to put a 0 inside here. And same thing, that's going to actually mean that the only thing that you're going to see is the y values here. Let me use a little bit of whiteout real quick. There we go. Looky there, I have to use whiteout even when I use a video. Isn't that awesome? Okay, so now what we have is just this 6y here equals that 12 because the xy thing disappears. Hi, goodbye. And with a little bit of thinking, 6 times what is 12 is 2, so the y-intercept is 2. You put a 0 in for the x, and the y resulted in a 2. And using a coordinate plane, you're going to go right here. X line, Y line type of thing. Whoop, 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 whoop. Give yourself some little values here. This is probably not my best coordinate plane, but you'll get the point. And the first one we found out was negative 6, 0. Oops, need some more things there, don't I? 1, 2, 3. Okay, so negative 6, which means it's going to be right here, and 0. An intercept on the x-axis. That's the whole thing, x-intercept. And then we're going to have the y-intercept, which is going to be at 0 and a positive 2. There we go. 2 points makes a line. Get your nice little straight edge out. Make your line. And there's your equation, graphed on a coordinate plane. All right. Now that you've done all that, go eat some cupcakes.